For all the exams, I turned on the lockdown browser. So for the rest of the tests of this semester, so I just want to see, because a lot of people who you guys are in here, they're in the classroom. I see what you know and what you don't know. But everybody who's doing this stuff online, I don't see what they know. I don't see what they so I need to know what they know. And it's too convenient nowadays to be able to, well, I don't know this question. I'll just copy it, put it in this AI app, and it'll show me step by step what to do. Oh, here's the answer. I'll put it over here. Not bothering. Let me figure out why I did this wrong. Yeah, so it records everything, and you have to activate it and download it. Mhm. Wait, and that's why every time we get to a process, the first thing I do, here are the step by step by step. Here's the roadmap, and then let's do it. And it works on all the problems, and that's exactly that's all you need. Yeah, and worst case scenario, if that doesn't help, then contact me. You don't have to go and go here get a tutor over here or buy your own
I was
tutor.
going YouTube. This tutor named Professor Lin. I don't know if you
I
know.
have no. There's so many of them out there.
Yeah, Professor Lenore. He has like the whole entire course right now, but he doesn't have it like in the order you have it. He has it like functions, equation, linear equations, and like quadratic, like.
Yeah, so you get I have to follow it because of it's people follow it through the book, so I have to go with the book. I would arrange it differently, but I gotta go with the textbook. All right, so let's review real quick. When we did yesterday, let's look at two options here. If we had let's look at both of these. They're actually inverses of each other. What does that mean? In other words, one is used to find the other. They're one's the opposite of the other. So in the first one, the left one, how would you solve for x here? The square root it because it's squared. We square root both sides. Okay, so the square root and the square cancel. So what happens on the right hand side? No.
Oh, plus.
Because what this means, let's look at it in a simple one. Let's say we have x squared equals 4. When I square root this, x can equal 2. We know that, but 2 times 2 equals 4. So does -2 times -2, that equals 4. That's why we put a plus or minus. It's two solutions. Like I said, it's supposed to be two solutions. All right, so whenever you square root something squared, make sure you put a plus or minus in front of the answer. So you square root a squared number, place a plus minus in front of the answer.
And so when you already have a square root, you square it.
Well, yeah, it's we have to write this down first. Everybody okay with this? Yes. So if you have a square root, so the opposite of square root is squared. So the opposite of squared is square root. Get it? So here's square root. So to get rid of the square root, I have to square both sides. So the square root and the square cancel. Now it becomes 49. Okay, so this process works for even powers. In other words, if that power is even, you have to follow the same rules. And even roots. If your root is even, you have to follow the same process. All right. So what does all this stuff mean? Because right now the power is 2 and the root is 2. What if it was 3? Write this down. What if we had, what if we had a cube root of 8 and x cubed? Or so now we have an odd root and an odd exponent. So how do we get rid of the cube root? Whatever is here, that's what you raise to the power because they cancel each other. And 2 cubed is 2 times 2 times 2, which is 8. If we have a cube root, then we have to cube it to get rid of it. So we have to put cube in here. This is 2 times 2 times 2, which is 8. And the other side, if I have x cubed equals 2, how do I solve for x? This is an exponent, so I have to cube root both sides. That is for that. I should have left it up there so we see what's happening. So that's what we started off with. So to get rid of the cube root, we put that cube on top of both of them. And to get rid of x cubed, we cube root both sides. So those cancels, give me x equals the cube root of 2. Notice I don't put a plus or minus in front of it. There is no plus or minus. Why? Because whenever you have an odd powered root or power exponent, the answer can be positive or negative. Yeah. Do not place a plus or minus in front of the answer. Because the difference here also is I can now have negative numbers. And if the root or the exponent are odd, I can have negative answers, negative numbers. So how do we solve this one? To get rid of the cube root, we cube both sides. So the cube root and the cube cancel each other out. And negative 2 cubed is negative 8. And the other side, how do we solve this one? Since it's an x cubed, I take the cube root of both sides. So the cube and the cube root cancel. So the cube root of -8 is -2. The answer can be positive or negative if the power is odd or if the root is odd. All right, so that's important, whether it's odd or even. It's cube root. If it's odd, if the answer here is negative, this answer is gonna be negative. Because remember, if we had x squared cannot equal -4 because no numbers together give you a -4. So that's the separation between the odd and even roots and powers. In general, if we had the nth root of x equals some number a, how do we solve for x? Right. Whatever's on the in here, you put it up here. And those cancel, so you have x equals a to the n. And converse. This is just a general rule we haven't talked about yet. If we have x to the power, any power equals some number, then we have to take the nth root, right? Plus or minus only if n is even. Actually, and we know this already because if we look at the graph of our functions, it tells us all this. I'll show you. So here's the graph of x squared and the graph of square root of x. So the graph of x squared is a parabola. Notice there's no negative answers. So the answer can never be negative. That's how come we can only have positive answers. And the square root, the smallest it can be, we cannot put negatives in there and we cannot get negative answers. If x is x cubed, or if f of x is the cube root of x. Then for the cube root, x cubed, the answer, you can put negatives in there and get a negative answer. or you can put positives and get a positive answer. Basically, it's all real numbers. The input and the output will be all real numbers. And for the cube root, we have that graph. So your input and output can be negatives, which is what we just talked about. So that's what we did in section 4. In section 5, equations and inequalities with absolute values. We've actually talked about these at the end of chapter 1. So here's the rule first. Rule 1. For equality. The absolute value of x, if so, equals some number. What do we know about the absolute value? Can it ever equal a negative answer? No. So a has to be positive. So whatever the absolute value has to equal a positive answer. And the same thing with the radicals. We have to isolate the absolute value in order to solve them. It's the same as the radicals. We have to isolate the absolute value to solve them. Once we get the absolute value by itself and we drop the absolute value, once we drop the absolute value, then the answer becomes a positive and a negative. Why is that? Because the definition of an absolute value is the distance the number is from 0. Absolute values, the distance a number is from 0. So if we drew a graph here, here's 0, and let's say that's a. That's a units away from 0. But if the absolute value of x is equal to a, and I drop the absolute values, then a can be positive or negative. Why? Because they're both the same distance away. They're both the same distance away. So that's when we drop the absolute value away, it becomes plus or minus the answer. Solve for x. Yeah, x equals plus or negative 5. So far, so good. So here's example 2. The absolute value of x minus 3 minus 1 is equal to 4. It's the same process we did with the square roots last time. So what's my first step? Add one, get rid of, because we're isolating the absolute value. So we add one to both sides. We have absolute value of x minus 3 is equal to 5. Is the absolute value isolated? Well, yeah, there's nothing in front of it, behind it, above it, or below it. So it's isolated. It's all by itself on the left. So to get rid of the absolute value, what do? I drop it and I put plus or minus in front of the 5. Drop the absolute value symbols and place a plus or minus in front of the answer. Yeah, here's a point. You need a pencil? Oh no, that's all mine. I'm glad you're doing that. Okay, so now are we done? No, because we're solving for x. So what we have to do here is we have to write our two equations down. Then we solve both of them separately. Add 3. So x is equal to 8. Add 3. X is equal to -2. Always check your answer. Now, CYA. Because our original equation was absolute value of x minus 3 minus 1 equals 4. Absolute value of x minus 3 minus 1 equals 4. So I'm going to check to see if x equals 8 works and see if x equals -2 works. So plug them in there. 8 minus 3, absolute value minus 1. Does that equal 4? What is 8 minus 3? What's the absolute value of 5? 5 minus. So 4 equals 4. So that works. We do the same thing with -2. -2 minus 3 minus 1 equals 4. -2 minus 3 becomes -5. Absolute value of -5 is 5. 5 minus 1 is 4. So they both work. So that, because like last time, it may not work, depending on how this question is set up. What's the absolute value of -5? What's the negative absolute value of 5?
Negative.
Why is it -5?
Is your-
Yeah, because negative's outside. Order of operations, yeah. You do the 5, absolute value of 5 is 5, negative in front of it. -5. For the same reason you just said. Because the negative is outside. So the absolute value of -5 is, and the negative still out in front. You just told me the answer.
I know, that's, I'm like, wait a minute, that's
That's the most common, because a lot of people think you distribute negative, negative makes it positive. No, not in this case. So yeah, I try to put it in there because you will see situations when that happens. They don't cancel each other out. It's an operation. It's order of operations. This is a special function. Okay, let's look at another one. I'll make up another example here. Have we got that? We got this? All right. Make it 7. There. This is my own homebrewed example. So what's my first step? What do you get rid of first? 3. 3, because it's not anything that's not physically touching the absolute value you get rid of. This is a constant, get rid of it. How? Subtract 3 both sides. So those cancels. We have -2, absolute value of 1. 7 minus 3 is 4. Next step. What's in front of the 2? Yeah. Get rid of the negative. You change the signs across the board. Next step. You try to get the absolute value by itself. Is it by itself? Yeah, it's got a 2 in front of it. How do you get rid of the 2? Since it's multiplied, we divide both sides by 2. Twos cancel. -4 divided by 2 is -2. And what's my next step? So if we drop the absolute value is by itself, which is what we're trying to get to. So if we drop the absolute value, what do we get? So plus or minus 2. Okay, we'll see that. So let's check our answers. Oh, no, we're not done yet. We have to, so we have x plus 1 equals +2, x plus 1 equals -2. Subtract 1 from both sides. You get x equals 1, x equals -3. So now we can check our answers there. So let's write down the question. This is the original question, because now we're going to change the values of x. So it gives us 3 minus 2, absolute value of 1 plus 1 equals 7. 3 minus 2, absolute value of -3 plus 1 equals 7. So far, so good. All I did was substitute in there. So let's work them out. Order of operations, we got to do it inside the special operation first. 3. 1 plus 1 is 2. Next step, we'll do the absolute value of 2. What is the absolute value of 2? Next step, multiply. 2 times 2 is 4. 3 minus 4 is -1, it doesn't equal. So that's not going to work. How about the other side? What do we do first there? Inside the special operation. -3 plus 1 is -2. Because they're opposite signs, you subtract. What's the absolute value of -2? Multiply. 3 minus 4 is -1. That one doesn't work. ¿Por qué no? We knew it wasn't going to work. We knew it right here. Can an absolute value ever equal something negative? No solutions. We knew it there. But you all wanted to go further, so we went further. Whenever the absolute value is by itself and it equals something negative, then there's no solution. And that's why it's important to make sure you get to this point where the absolute value, nothing in front of it, nothing, there's no negative sign in front of it or anything. But if there was a negative sign in front of you here, then I have to change both signs and then it would work. But because it doesn't work that way because it's negative. All right, so that's with equality. Let's look at with inequalities. There are two separate rules here because we have two basic inequalities, less than and greater than. So let's look at both sides. And we know from the equality symbol that when we drop the absolute value, we have to make sure we have a plus or minus. We have two answers. Before we go further, why do we have two answers? What's the formula for absolute value? If you had to put a formula with what we know so far, even what we talked about today, the operations we use today, what is the formula for absolute value? Or I should make it X in here. The absolute value is actually the square root of X squared. Here's the reason why that works. If we have a number inside there, 2. So what's the absolute value of 2? We know it's 2. Let's look at the formula. What do we do first in this equation? 2 squared. No, don't cancel anything out. We need everything. 2 squared is, what's the square root of 4? 2, which is what that is. We have to keep it that way because what if we had a negative number in there? Why does it become a positive? What's using the formula? So if we had -2 squared, what is when you square something? What happens to it? It always becomes positive. -2 times -2 is +4. So the square root of 4 is 2. So that's the reason we square it first to get rid of the negatives, and then we square root it to bring it back down. So that's the formula for the square root symbol. That's why it always works. All right, back to the lecture. Let's look at the graph of these first. Remember, we said that the definition, that the purpose of an absolute value is tell us the distance a number is from zero. So if this is A, and we're looking at X is less than A, and here's zero, so what side of A is our answer on? Left or right? It's left because it's to the left of it, right? So if we have a negative A, because we have to have both sides, positive and negative, it's going from A to zero, so it's over here. Follow me so far? So if we had the absolute value is less than A and we drop the absolute values, it will become this equation. If it's a less than, that means negative A to zero and A to zero. That's the part we're looking at. Everything between A and negative A. So less than is this intermediary part. This other side, there's zero, there's A. If I'm thinking of a number greater than A, which side is shaded? To the right. It's going away from zero. So what's it going to do at negative A? It's going to go to the left because it's going away from zero. It's opposite side. It's going away because if we took these numbers and took the absolute value of them, they're going to be over here. So it's a mirror image. This gives us a mirror image, a reflection about zero. So these come over here. These come over there because I'm reflecting about the zero. So how would I put this? X is less than negative A, or X is greater than A from our inequality sheet from chapter 1. So these are the rules. So these are the rules. All you have to do is, you don't have to memorize it. Just think about what they mean. Look back at these pictures. If it's greater than, it's going away from zero. So it means it has to go, both directions has to go away from zero. If it's less than, then it's going between zero and that number. So let's look at an example here. Absolute value of 3x plus 2 is less than 5. This was asking solve and graph that function. So your first step is always to do what? Or no, you can't do anything inside. You have to get what by itself? Get absolute value. Isolate the absolute value first. Check, it's there. Now we can drop the absolute value. It's less than. So it looks like this. This is the answer. So I have negative 5 is less than, this is my x, is less than 5. X represents anything inside the absolute value. Now we solve for x. What do we do first? Where's the only x on this equation? 3x plus 2. So we look at this, solve for x. What do we get? What do you do first? Minus 2. Again, we did this in chapter 1 when we did inequalities. -5, -2 is -7 is less than 3x is less than 5 minus 2 is 3. All right, what's the next step? Remember, only look at the part that has an x. We're trying to get x by itself. So what do? Divide everything by 3. So we have -7 over 3 is less than x is less than 1. There's the answer. So let's graph it. We have -7 over 3, and we have 1. Are they open or closed circles? They're both open circles because we cannot use the numbers. They have no line underneath them. So where's the shaded region? X is between them. There's the graph. Pretty good. Makes sense. So whenever you have these, whenever you have a less than, you're going to have a tripartite equation. Only look at the middle part and solve for x. All right, the next example. Everybody finished writing? Absolute value of 5 minus 2x is greater than or equal to 1. So this is, we're using greater than, so we're going to use this rule. That rule says when x is less than that, or x is greater than that. That's the rule we're going to use. Remember, anything inside the absolute value is what x is. So in this case, what is x? Yeah, 5 minus 2x is less than the negative of the answer. That's what that says. Here's the answer. That's 1. So it's less than -1. Or the x is 5 minus 2x is greater than or equal to, in this case, it's equal to also, a, which is 1. If it makes it easier for you, label what is x and what is a. So we can copy this equation. What is x in our example? 5 minus 2x. Whatever's inside the absolute values. And a is 1. Of course, you can't do this unless you have the absolute value by itself. You have to isolate the absolute value first. Now we solve for x. So what's my first step? Nope. Yeah. You have an equation here. There's x. Is there anything not touching x? The 5. So you subtract 5 from both sides. The fives cancel, so we have negative 2x is less than equal to negative 1, negative 6. It makes it negative 5, makes it negative 6 total. There's the same signs, you add the numbers. The fives cancel, so we have negative 2x is greater than equal to 1 minus 5. 5 is bigger, so the answer is negative. 5 minus 1 is 4. You know, everything we're doing is the same stuff we've done since day 1 in this course. Every procedure, every step is always the same. What's my next step? No. Switch the signs, because that's okay here. Remember, now we're dealing with inequalities, so everything has to switch. Go step by step by step in towards the x. So negative, so we have positive 2x. This one becomes greater than equal to, and it becomes positive 6. That one becomes positive 2x less than equal to positive 4. Change the signs, change the inequalities. Remember, you have to work your way to the x. You can't just jump in there and say, do that. So what's my next step now? Now I divide by 2, because the x is not by itself yet. So x is greater than equal to 3, or x is less than equal to 2. There's your answer in interval form. What's the graph going to look like? So here we draw a line. We have a number at 2 and a number at 3. Open or close circles. They're both closed. So from 2, which direction am I shading? X is less than 2. So less than is this way. And then x is greater than 3, so it's going over here. Remember, if you have x on the left-hand side, then the arrow tells you where to shade. It says shade to the right of 3, or shade to the left of 2. So far, so good. And remember, we could have also done it with that notation. All right, so that's the end of that section and the end of that chapter. Which means